Obtain the Fourier series of the periodic function f of x equal to e power ax in the interval 0 to 2 pi. So in this interval, f of x is a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity bn sin nx, where a naught equal to 1 by pi integral 0 to 2 pi f of x dx. Now I am going to substitute f of x is e power ax 0 to 2 pi e power ax dx equal to 1 by pi e power ax divided by a. The integration of e power ax dx equal to e power ax divided by a is the formula. I have used this formula here, which is equal to 1 by pi. If you substitute upper and lower limit, e power 2 pi a instead of x, you have to substitute minus e power a into 0 divided by a. So you can take from that you make it 1 by pi. You can take a as a common term. From that you make it e power 2 pi a minus 1. But you can rewrite this term as 1 by pi a e power pi a into e power pi a minus 1. If you take e power pi a as a common term in this close bracket, you may get e power pi a minus e power minus pi a. Right? If you multiply this term to close bracket, you may get the original term, previous term. Right? So which is equal to e power pi a divided by pi a into e power pi a minus e power minus pi a. You can multiply and divide by 2. So from that you may get, you can rewrite this term as e power pi a divided by pi a into sin h pi a, sin pi a. Already you know the formula. Sin h a equal to e power a minus e power minus a divided by 2. This is the formula for hyperbolic function. So I have replaced this term to e power pi a divided by 2 pi a into sin h pi a. This is a naught. Next one is a m. 1 by pi integral 0 to 2 pi f of x cos nx dx. So now I am going to apply 0 to 2 pi f of x is e power ax cos nx dx, which is equal to, before that you must know the formula for e power ax cos bx dx, which is equal to, because here we can't apply Bernoulli formula. We want to apply Bernoulli formula. The the product of among between the product of two terms, any one should be a algebraic. But here we can't apply Bernoulli formula because suppose if you take any term should be u, their successive derivative is not going to be vanish zero. It's not going to be get zero. So for that, I'm going to apply this result e power ax divided by a square plus b square into a cos bx plus b sin bx. This is the formula I'm going to apply here. So here there is no limit is given. You have to apply after using this formula. You have to apply the limits. That's all. So which is equal to 1 by pi into instead of this integration I'm going to apply e power ax divided by a square plus, so here b is nothing but n, so n square a cos nx plus n sin nx, upper limit and lower limits. Right, next one. Now I'm going to substitute. So here you can take a square and n square as a constant. Comparing x, you can take it outside from this closed bracket. So from that you may get 1 by pi into n square plus a square into e power ax a cos nx plus b remains n sin nx 0 to 2 pi. Now I am going to substitute x in upper limit, that means 2 pi, which is equal to e power 2a pi. We apply inside the closed bracket, you may get a into cos 2n pi plus n into sin 2n pi minus lower limit e power 0 is 1 a cos 0 plus n sin 0. Now you can apply cos n pi equal to minus 1 over n, cos 2n pi equal to minus 1 power 2n, which is equal to 1, cos 0 equal to 1, sin 0 equal to 0, e power 0 equal to 1. So all those things you have to apply in those steps. From that you may get e power 2a pi into this term is going to be 1, this term is going to be 0. Here you can apply this term is equal to 1, the last term is going to be 0. So from that you may get e power a pi e power 2a pi a minus 1, right? Which is equal to, similarly in like a previous calculation, I'm going to take, here I forgot to put a, so please put the a. You can take a as a common term. And also you can rewrite this term as e power a pi into e power a pi minus 1. which is equal to e power, I have taken a power a pi as a common term in this closed bracket. So from that you may get e power a pi minus e power minus a pi. So you can rewrite this term as a e power a pi divided by pi n square a square into 2 sin h a pi, 2 sin h a pi. So this is for an. An equal to 2a e power a pi by pi into n square plus a square. Next one, bn. Bn equal to 1 by pi integral over 0 to 2 pi f of x sin nx dx, which is equal to 1 by pi integral over 0 to 2 pi e power ax sin nx dx. Now I am going to apply this formula. Integral e power ax sin px dx equal to e power ax divided by a square plus b square into a sin bx minus b cos bx plus c. If you apply this formula, you may get 1 by pi into e power ax divided by a square plus n square into a sin nx plus, sorry, minus n cos nx. So if you want to apply this formula, instead of p you have to put n. So I have substituted, instead of b is n into, and also after applying this formula you have to substitute upper limit and lower limit, which is equal to e power ax divided by a square plus n square. Now I am going to substitute upper limit first. So a sin 2n pi minus n cos 2n pi minus lower limit. So instead of x you have to substitute 0. So e power 0 divided by a square plus n square into a sin 0 minus n cos 0. Now you can apply, that means this term is going to be 0, this term is going to be 1. If you get this is 0, cos 0 is 1. So here comparing these terms, both are common for each term. You can take it outside from this integration. So from that you can write a square plus n square into e power, here I forget to apply 2 pi, e power 2 a pi into minus n minus of minus n, which is equal to, here you can take this term is going to be common. So n by, which is equal to If you take minus as a common term, minus n as a common term, you can write minus pi a square plus n square into e power 2a pi minus 1. So by using, already we have applied the same logic to find a naught here, this term. So similarly, I'm going to the same logic to find. I'm going to apply the same logic here also. So directly I'm going to apply the result. So you can rewrite this term as e power a pi divided by pi a square plus n square into 2 sine h a pi. This is bn. Now I'm going to apply a naught an bn in the expression, in the above expression. That means in Fourier expansion formula. So from that I'm going to get, so f of x equal to, this is Fourier series, a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. Now I am going to substitute these values, which is equal to, you may get e power a pi into sin h a pi divided by 2a pi. You can cancel these two terms, plus summation n is equal to 1 to infinity 2a e power a pi sin h a pi divided by pi a square plus n square cos nx minus summation n is equal to 1 to infinity 2n e power a pi sin h a pi divided by pi a square plus n square sin nx. So this is the final answer. Next one. Here is the next question. So here in this problem, we want to find the complex form of Fourier series. Complex form of Fourier series. So here in this formula, in this question, the interval is minus 1 to plus 1. So plus minus 1 to plus 1 is, already I have given the formula earlier, n minus L2 plus L minus L2 plus L. I'm going to apply f of x equal to summation minus infinity to plus infinity cn e power I n pi x divided by L, where cn is nothing but 1 by 2L integral over minus L2 plus L f of x e power minus I n pi xl into dx. So this is the formula for given expansion. So the specialty of complex Fourier series is, here Only it's enough to find Cn only. In previous cases, we have calculated three terms. So that we combine all together, you may get Cn, the simplest form of Fourier series. But both are same. You may get, if you expand, you may get the same value. But here we are combining an, bn together. This is known as Cn, right? Now I am going to find. Before that, the number is given. So in this interval, -1 to +1 is given. So from that you have to identify Ls minus, that means L is 1. You have to compare these two things. So I'm going to take here L equal to 1. That means you can rewrite this formula as f of x Fourier series of this function as summation n is equal to minus into plus infinity Cn e power I n pi x. No need to put divided by n, where Cn equal to 1 by 2 only, -1 to +1 f of x e power minus I n x I n pi x dx. Now I'm going to find Cn. So 1 by 2 integral over -1 to +1 e power minus x into e power minus I n pi x dx, right? Next one is, now I'm going to multiply these two terms. So 1 by 2 integral over -1 to +1 e power, if you take minus as a common term, you may get x plus I n pi x into dx. But here we can't apply even the odd condition property because the exponential function, this function is neither odd nor even. So here in this function we can't apply because the limit is upper and lower limits are numerically same. But here we can't apply because this is neither even nor odd. So directly, as well as by using the same function, as usual, you can integrate and you have to substitute upper limit and lower limit. You may get some value, right? So now I'm going to integrate. If you integrate, before integrating, I'm going to rewrite -1 to +1 e power minus 1 plus I n pi x. I have taken x as a common term in this close bracket. This is equal to 1 by 2. If you integrate, you may get e power minus of 1 plus I n pi into x divided by minus of 1 plus I n pi and upper and lower limits. Right? Next one is, which is equal to 1 by 2. I have taken minus 1 plus I n pi as a common term. You take it outside from this close bracket. So from that, minus 1 plus I n pi into e power minus 1 plus I n pi x minus 1 to plus 1. Minus 1 to plus 1. Now I'm going to substitute the values 1 by 2 minus 2 into 1 plus I n pi into, I'm going to split the term e power minus x into e power minus I n pi x, which is equal to minus 1 by 2 1 plus I n pi equal to into, if you apply e power 1 you may get e power minus 1 into e power minus I n pi. After that you have to apply lower limit also. So if you apply x is equal to minus 1 you may get e power 1 e power I n pi, right? So already know the formula, e power I theta equal to cos theta plus I sin theta. Suppose e power minus theta is coming means you have to put cos theta minus I sin theta. And also you know that cos n pi equal to minus 1 power n sin n pi equal to 0, right? So now I am going to apply these values. So minus 1 by 2 1 plus I n pi into e power minus 1. If you apply this formula you may get cos n pi minus I sin n pi minus e power 1 into cos n pi plus I sin n pi. I have substituted the formula for these two numbers, two functions, which is equal to minus 1 by 2 1 plus I n pi e power minus 1 into cos n pi minus e power 1 into cos n pi. This term, I think this term is going to be 0, right? After that you can rewrite like this. Now I'm going to take cos n pi as a common term, and also I'm going to multiply minus inside the close bracket. So from that you may get 1, that means cos n pi into 2 into 1 plus I n pi in the close bracket you may get e power 1 minus e power minus 1. If you multiply the minus inside the close bracket, now you can rewrite cos n pi divided by 1 plus I n pi into e power 1 e power minus 1 divided by 2. So this is nothing but cos h a equal to e power a minus plus e power minus a divided by 2 sin ha equal to e power a minus e power minus e divided by 2. Now I am going to apply second formula. So from that you may get cos n pi divided by 1 plus I n pi into sin h1. So already you know that value of this one is minus 1 power n. So minus 1 power n sin h1 divided by 1 plus I n pi. This is Cn. Now I'm going to substitute Cn in the complex Fourier expansion. So which is equal to, so therefore Fourier series of that function e power minus x equal to summation n is equal to minus infinity to plus infinity. Instead of Cn, I'm going to apply this value minus 1 power n sin h1 divided by 1 plus I n pi into e power I n pi x. So this is the result. So half range sine series of f of x equal to x power 3 in the interval 0 to L. The formula is f of x equal to 2 by L integral over 0 to L f of x equal to summation n is equal to 1 to infinity bn sine n pi x divided by L, where bn is equal to 2 by L integral over 0 to L f of x sine n pi x divided by L dx. Right? Now I'm going to use this formula. So bn equal to 2 by L integral over 0 to L x power 3 sine n pi x divided by L dx. So now I'm going to apply. So here I'm going to apply Bernoulli formula. Bernoulli formula is nothing but integral over d uv integral uv dx equal to uv1 u dash v2 plus u double dash v3 and so on. So now I am going to take this is u, this is u, the remaining term is v. So here in this polynomial the power is 3. So for that you have to extend, you have to give, you have to put the 4 pair of close bracket because we may get 4 terms. So I am going to apply 2 by L into, like this I am going to do. So in this way you can easily get the answer quickly. So for that I prefer to apply, I recommend you can do this problem like this. From that you can easily identify the answer. Now I'm going to start with first close bracket I'm going to differentiate consecutively. I'm going to differentiate x power 3 successively. So now first I'm going to take u as same x power 3. Now next close bracket only I am going to fill the first close bracket in each pair. So x power 3, if you differentiate x power 3 you may get 3x square. Again if you differentiate you may get 6x. Once again you have to differentiate. From that you may get 6. Now next one is, now I'm going to do, I'm going to take this term as the integration of this term you have to take. So integration of this term is minus cos n pi x divided by L divided by n pi by L. Right? Again you have to integrate. So if you want to fill the first term, you have to differentiate. You have to put the successive differentiation of x power 3. In the second term of each close bracket, you have to put successive integration of v. But you have to start with first integration. But in the first term, you have to start with normal term, same term. After that, you have to do successive differentiation. So try to apply correctly. So here, by using this term, if you integrate, you may get minus sine n pi x divided by L divided by n pi by L whole square. Again, you have to integrate. If you integrate, you may get minus of minus because one minus is there. If you integrate sign, you make it plus. So plus cos n pi x divided by L divided by n pi by L whole power 3. Once again, you have to differentiate the previous integration. That means you may get sine n pi x divided by L divided by n pi by L whole power 3. sorry 4, because already 3 is there. Again you have to include, you have to multiply the another coefficient of x, you make it power 4. So before that, now I'm going to preview the sign terms, whether it's going to be vanish if you apply x is equal to L as well as x is equal to 0. Particularly in sign terms, I'm going to check now before substituting all the elements value, right? Suppose here, among these four terms, second and fourth term, which contains sign. So for that, I'm going to check the terms, whether it's going to be vanish when you substitute x is equal to L and x is equal to 0. So sure, and definitely it's going to be 0, right? Suppose if you apply x is equal to L, you may get n pi L divided by L. It's going to be n pi. So sine n pi, already you know the value. Sine n pi is 0. Similarly, if you apply x is equal to 0, you make it sine 0, it's going to be 0. So from that, before substituting all x, you can eliminate second term as well as fourth term. That term is going to be 0. After that, you can somewhat simplify the terms. After the simplification, you can substitute the elements for remaining terms. So from that, you can reduce the mistakes, right? Next one, I'm going to write the remaining terms. You can multiply, you may get the L, which is going to be numerator. If you multiply x square, x power 3 into minus, you make it minus x power 3. So I'm going to write 2 by L minus L x power 3 n pi cos n pi x divided by L. I think you have to put capital L. So that thing I have written in next page. Again, you have to write these terms also. So you may get plus 6x L cube divided by n cube pi cube cos n pi x divided by L. Now you can substitute upper and lower limits. So from that you may get 2 by L minus L x power 3 divided by n pi. If you apply upper limit, you may get cos n pi plus 6x L power 3 divided by n cube pi power 3 cos n pi minus, you have to substitute lower limit also. Suppose if you substitute lower limits, no need to, if you the product of any terms, if one term is going to be 0 means the entire term is going to be 0. So no need to substitute both x. So now I prefer to substitute x is equal to 0 in the x power 3, right? So from that you may get, so I forget to substitute x is equal to L here also. So please try to substitute L here also. So from that you may get L. If you apply the lower limits, you may get both terms going to be 0. So from that you will get 2 by L minus L power 4 minus L power 4 divided by n pi cos n pi plus 6 L power 4 divided by n cube pi cube cos n pi. So now we have to compare whether is there any common terms we can take it outside from this close bracket. I think L power 4 cos n pi and n pi is also common, right? So if you take, you may get 2 L power 4 cos n pi as a common term. You can get, if you take all those things, n pi also common for these two close bracket, these two terms. If you take, you may get minus 1 plus 6 by n square pi square. I think you can cancel these terms. From that, you will get 2 into minus 1 power n divided by n pi into, after taking LCM, you get 6 plus, I have written directly, I am writing directly, 6 minus n square pi square divided by n square pi square, which is equal to 2 power minus 1, 2 into minus 1 power n into 6 minus n square pi square divided by n square pi square. This is Bn. So by Fourier half range sine series, we can substitute Bn in the formula expansion. So from that you make it f of x equal to summation n is equal to 1 to infinity 2 into minus 1 power n divided by n power 4 pi power 4 6 minus n square pi square. So I have written correctly into sine n pi x divided by L. So this is the half range Fourier sine series of f of x in the interval 0 to capital L. That's all.